Hey guys, I'm back. Today we're going to do a lesson on trigonometry of angles. The first two lessons kind of more focused on the ratios and figuring out what those ratios are, especially with the special angles and what those ratios were. And then lesson two talked about ratios of any angle. But now we're going to talk about finding angles. If we know what the ratio is, how do we find the angles and how do we know which angle we actually have? Given that, for example, sine is positive in both quadrant 1 and quadrant 2, how do we know that when we're solving problems, we're not talking about the acute angle or between 0 and 90 or the angle that lies between 90 and 180? Because in both cases, sine is positive. And that's one of the things we have to kind of figure out and we have to work with. So it's kind of also good to know that when we're dealing with angles between 0 and 360, a lot of the times the ratio will give you one angle, but it could be that you could have another angle. There are two answers for all of these questions, basically, unless they say specifically that it's only between like 0 and 90, then obviously there would only be one answer. But if we're looking at the circle from 0 to 360, we're going to have two answers. So that's basically what the key concept says. Exactly two angles between 0 and 360 have the same sine ratio. So for example, sine theta is equal to sine 180 minus theta. So that has to do with quadrant 2. Exactly two angles between 0 and 360 have the same cosine ratio. Exactly two angles between 0 and 360 have the same tangent ratio. And that's where we get into our unit circle. So I'm going to kind of go over some of the stuff we already know, but you're going to have it all in one spot this time. So this is quadrant 1. So I'm hoping that we kind of sum everything up. This is 90 degrees. Down here we have 180. This is quadrant 2. I'll try and make it smaller. Quadrant 3 down here. And quadrant 4. Now, what happens is they kind of do it like this. So if this is our angle theta here, our sine ratio is going to be the same this way, where here it is 180 minus theta. Okay? Because it's 180 and we're going back. Those are, theta is the reference angle for this 180 minus theta angle. You also have, down here, I just kind of want to make it so it's the same. This would be 180 plus theta. And this one here on this side is 360 minus theta. So these are all common, or all refer to the same reference angle. The difference between which ones are actually equal depends on which quadrant they are positive and negative in. So I'm going to write those in here as well, just for your reference. So remember I said that we had the cast rule. So down here is our C. This is A. S because sine is positive there, and T is this quadrant. So in this one, cos is positive. That's how I remember it. Cos is positive. In here, all are positive. In here, sine is positive. And in here, tan is positive. So the one thing to kind of like, how do you know there's two angles that are the same? If you have a ratio, let's say for example, sine is equal to a negative, then I then know that we're going to have our angles in quadrant. When you got to ask yourself, when is sine negative? Sine is positive in this quadrant 1 and positive in quadrant 2, which means that in order for sine to be positive, both my angles are going to be down here in quadrant 3 and quadrant 4. Okay, let's say, let's do another quick example. Let's say that we know that our ratio of tan is negative. A negative ratio. Then I will look at and see, well, where is tan positive? Tan is positive in quadrant 3 and quadrant 1. So it means that I'm going to get two angles, and they're going to be in quadrant where tan is negative. Tan is negative in quadrant 2 and quadrant 4. That means I'm going to have an angle that is between 90 and 180, and an answer where the angle is between 270 and 360. I forgot to put them on. Let's put them on. 270. And this is 360 or 0 when it starts. Now that we have that, you guys have that in your notes, kind of a nice reference to have along with your special angles. Keep this one handy. Let's move to this next page and we'll do an actual example so you can see how the numbers actually work out. Okay, so here we are. We've got an example. Given that cos theta is 4 over 5, let's determine theta, which is the angle, where it is between 0 and 360. Now, anytime it's between 0 and 360, I'm going to think two angles. So therefore, there are two answers. So I am looking for two answers. The other thing I'm going to take note of, and I'm kind of going to highlight it, is that cos theta is 4 over 5. Now, I've noticed that cos theta equals 4 over 5. And I'm noticing that it's positive. So then I kind of think to myself, which quadrants is cos positive? So we go back, if you go back and look at it, cos is positive in quadrant 1, which is 0 to 90 degrees. And it's also positive in quadrant 4, which is 360 or 270 to 360. So not only do I know that I have two angles or two answers, I know that one of those angles is going to be between 0 and 90, and one of them is going to be between 270 and 360. So the thing that you're going to do, first of all, is your calculator is only going to give you one of those answers. But that is okay because once your calculator gives you one of those answers, you can easily find the other one by doing what's written on our like little chart, which I'm going to explain in a sec. So your calculator, usually the calculator defaults to quadrant 1. This is usually the calculator default. Unless, the only exception with that is if you have, I think it's when cos is negative ratio, but because then it actually will give you a negative answer. So all you have to do is like change that into a positive angle between 0 and 360, which is super simple to do. So let's look at this. Our calculator default is between 0 and 90. So let's actually calculate cos theta 4/5. So I know that that is 0.80, and I'm going to calculate it 0.80 on my calculator. I haven't said it yet, but when we're doing trigonometry, guys, please, 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 because we're dealing with degrees, make sure your calculator is in degrees. If your calculator does not have a DEG in the top of it, or it's not set in degrees, your answers are not going to be correct. So make sure your calculator is in degrees. So I'm doing second function cos 0.8 because I'm going to take the inverse. And what happens is I get approximately 37 degrees. It's okay to round it in this case. So that's one of the answers. Now, you have to do a little bit of thinking about that second answer because it is only going to give you the positive one, and usually between 0 and 90. So to find the second angle, all I'm going to do is go to that quadrant 4, and quad 4 says that it is 360 minus theta, and that's all we're going to do. So we're just going to find that fourth or that second angle, we're just going to do 360 minus the angle we found, 37 degrees. 360 minus 37. So it's 323. And there you have it. That is one angle that satisfies that ratio for cos, and this is the other one. So we actually get two answers. Kind of nice. And then what does it ask us? Then determine sine theta and tan theta. So we can then figure out what sine theta is. And you're going to do it for both angles because we have two different angles. So for sine 37 degrees, we'll calculate it, and then sine 323 and calculate it. And then we'll do the same for tan theta. So we'll calculate tan 37 and we'll calculate tan 323. Now, we are expecting that because between 0 and 90, all of them are positive, so our sine 37 and our tan 37, I should get a positive answer. But our sine and tan of 323, that's where cos was positive, so we should get negative answers for those ones. And you can just plug that in. 0.60 and sine 323 is negative 0.60. Tan 37, 0.75. and tan 323 is negative 0.75. And that is how you do it. If you want to be more exact, you go ahead and use the Pythagorean theorem, find out that third side, and then just leave them in fraction form. If you had done that, you would have got 3 over 5, negative 3 over 5, and this one would be 3/4, negative 3/4. If you did Pythagorean theorem and you wanted exact answers. But I'll take either way in this case, unless it specifically says so. And so that is trigonometry of angles and how to figure out what the angles are and which two answers you're going to use. I'll see you guys next time.